So let's go through these, and then, like I said, you'll get another chance. I have a second one ready for you. I'm hoping that whatever ones you missed, I can provide some clarity as to why you missed them. The goal is to, like, if you got 5 out of 6 today, you get 6 out of 6. I assume if you were absent that you did it online, but that's just how my brain works. So if you got 3 out of 6, I hope you get at least 5. We want to get better. That's the point. If you get 3 out of 6 and get 3 again, then we're kind of wasting taxpayer dollars here. You know what I mean? So let's get started. First one is just real simple factoring. Let's see. Yeah, this guy here. So this one, it's already ready to go. So it should have factored quickly into this, and you should have put your X's here. We know we need one positive, we know we need one negative, and it should have come out to +3 and -8 like this, because you need the balance to work out correctly to make the -5x in the middle. So your answers for this one should have been x equals -3 and x equals +8. Remember that the answers are the things that make the parentheses equal 0. So my intent putting that on there was that would be just a everybody gets it right kind of problem. No issues there at all. The second one is significantly more difficult. It's the same concept again, but again, significantly harder just because there's prep work involved, and the factoring also is a lot harder. So the mistake you don't want to make is pulling the 9x squared across to the left, because that makes him negative. So we want to leave the 9x squared where he is. You always want to leave that guy positive. When you're going to factor, that's important that you not put yourself through the stress of trying to factor when there's a negative in the front. You can do it, it's just poopy. So if I leave 9x squared, I pull the -3x and he becomes a +3x. And then I pull the +20 and he becomes a -20. And it's all of that I want to set equal to 0. And again, the factoring is just what it always has been, and that is just build your shells. And you can experiment with it, 9x, 1x, or whatever, but eventually you will figure out that you do need 3x's and you do need a 5 and a 4. I'm going to put the 5 here to make 15, and I'm going to put the 4 here to make 12. And then I want to make sure that when I add those together, because one's going to be positive and one's going to be negative, I want the net outcome to be positive. So I want to give the 15 the plus sign and the 12 the minus sign, like that. So that's just an expectation by now, is that you're able to factor something like that. And again, I got it on the first try because my intent is not to make this take a super long time, but just to show you the correct method. So it could have taken you 3, 4 tries to get there, 5, 6 tries maybe, but you get there. So the answers, remember, are the things that make the parentheses equal 0. So in this first one, it is negative, and we take the 5 and put it over the 3. And then on the second one, it is positive, and put the 4 over the 3. So those are the two solutions to that equation. Any questions on the factoring? You should be able to get those correct. Factoring is really just a matter of, there's not much to quote unquote get. It's just a matter of get in there and get it done. Like, you just play with it until it works. Numbers 3 and 4, I know they're not numbered, but the third and fourth problems are quadratic formula problems. And so for these, we're not thinking about factoring. We're thinking about, let's set it equal to 0, and then let's find our ABC and plug it in. So I'm going to leave the 12x squared where he is. I'm going to leave the -12x where he is, and I'm going to bring the 1 across, but rename him +1, like that. Okay. And then it's time, since it's the quadratic formula, it's time to identify our A, B, and C. So A is 12, B is -12, and C is +1. We're just going over the snapshots from Friday. Did you get one? And then there's another one today. So the quadratic formula is just something that you have, it's in the forefront of either your mind or your notes or both. And so we're going to start by saying x equals. And the first thing we do is take the opposite of b, which is 12, plus or minus, and then we make a big long square root sign. And inside that square root sign, the first thing we do is square b. So that's 144. And then we go -4 blank blank. And then we put that all over whatever 2 times a is, which in this case, 2 times 12 is 24. And then I'm going to go backfill my a and my c. So in place of a in this first parenthesis set, I'm going to put 12. And in place of c, I'm going to put positive 1. I would never buy it if someone said, I don't get that. Like like I said a while ago, there's nothing to get. It's just a formula and you just pop numbers in, do a little bit of math. The only math you had to do was taking the opposite of negative 12, which isn't really hard, and then squaring negative 12, which isn't hard. And then we had to multiply 2 times 12, which again is not hard. So at this point now is where you have to bear in mind that there could be a sign change or there might not be a sign change. So when I point to this minus sign, is that going to stay a minus or switch to plus? It's going to stay. It has no reason to change because there are no negatives later on down the line. So what this winds up being inside of the square root sign is 144 minus 4 times 12 times 1, which is 48. And what is 144 minus 48? It is exactly 96. So the next line of our answer should say x equals 12 plus or minus the square root of 96 all over 24. It's here where usually the stress and trouble arises. There should not be any issues before this point. It's real fundamental math. At this point, though, I know that teenagers don't like this, but you have to be good at breaking down a root. And so I go off to the side and I ask myself, how can I break down the square root of 96? So I make my little branches, make my little root signs. What makes 96? Right. And there is another combination, but it's no good. Right. So thank you for not picking the bad one. The good one is 16 times 6, which becomes 4 root 6. So at this point, you go into the problem and you swap out the root of 96 with his acceptable version of himself, which is like this. So you put in the 4 root 6 where he used to be. And then the last step is to acknowledge this little guacamole colored Dorito. And what can all those numbers in there be divided by? Yes. You divide them by as much as they all agree to, which in this case is 4. So you wind up making a 3, a 1, and a 6. The 1 does not need to be there, so our final answer can be expressed as x equals 3 plus or minus root of 6, don't need the 1, all over 6. Good. Any questions about that? These last 3 are the ones that got missed the most. So they're where I anticipate I might just get the most questions, but I don't know. Again, I'm going to leave 8x squared where he is. Don't move something that's got an x squared that's already positive. You're just making your life harder. The quadratic formula doesn't care. Like it'll take negative a's. It doesn't care, but your life will be easier if you always make sure a is positive. And that goes for a lot of instances, not just the quadratic formula. So I'm going to pull the 2x, make him plus. I'm going to pull the 5, make him minus. And now I'm ready to rock and roll. So my a value is 8. My b value is 2. My c value is negative 5. And then it's time. So I'm going to say x equals the opposite of 2 plus or minus a big long square root sign. Inside the square root sign, I first square b, which is 4, and then I put minus 4, and then I put 2 sets of parentheses. If you do this enough times, you almost can just fall asleep while you're doing it because it's like ho-hum. It's like the same thing over and over again. And then on the bottom, we do 2 times a, which is 2 times 8. And then I go and I backfill. A gets filled with 8. C gets filled with negative 5. So this minus sign, is he going to stay or switch? He's a switcher because there's a negative later on after him. And we know that they're going to meet eventually. So what's happening inside the square root sign is actually 4 plus. And then you just have to probably use a calculator, I'm guessing, right? And then you do 4 times 8, which is 32, and 32 times 5, which is 160. Again, notice as I say that, I'm not acknowledging the negative signs because I've already figured out that they're going to both go away anyways. Like, what's the point? So I arrive, as I always do, at this crossroads where I have negative 2 plus or minus the square root of just a number, 164. I'm going to put that all over 16, and it's time for our least favorite step, and that is breaking down the square root of 164. And it's a number that you've seen before, not like you memorize them every time you see them, but what is 164? It is 4 times 41. Every time you see one that you don't like, put it in your notes because you might see it again. And then you've got it there and you don't have to go and reinvent the wheel every time you see a number. You're like, I've done this. This one I put in my notes. So that becomes 2 roots of 41. And then again, I perform the swap. So I'm going to go back up to where it used to say root 164, and I'm going to improve that to say 2 root 41. And yet again, we see the Dorito, the triangle. And what can those all be divided by? 2. So this one becomes a -1. This one becomes a regular 1, and this one becomes an 8. And then it's time to write the answer. So our answer is going to be -1 plus or minus just regular root 41. Don't put the ones where they don't need to be. It's a bad habit. All over 8. That's it. Any questions on that? All right. The last 2 then are the ones where we use square roots. So no factoring, no quadratic formula. We're really trying to hit all 3 different methods here. So this first one, what do we want to do first? Add the 6, right? Remember, it's easy for us to just think of -6, but you have to remember when you move it that you're actually moving it to plus. So we wind up at 9x squared equals, it gets bigger, 432. What's the next step? Because I think this is the one that a lot of you need to hear. Not square root. And that's what I figured I would hear. You cannot square root until this thing, I'm going to put a red box around it. Until that thing in the red box is by itself, you are not green lighted. So that's a part where I expect to see some pencils or pens moving, because that I know from grading these last night was a real sore spot. A lot of people square rooted at that point. You're not ready for that yet. Divide away the 9 first. And then you wind up in a situation where you have finally what you want. X squared is by himself. And you got one of 2 things that's going to happen. Either 432 will divide by 9, in which case we'll be glad, or it won't, and then we'll be stuck with a fraction. Not a decimal, but a fraction. But in this case, 432 divided by 9 comes out really nicely to 48. So you wind up at this point in time right here. You have to get to the part where the square is by itself. No numbers in front, nothing. And now it's time to square root. And so when I square root both sides of this, I get x equals, and I write positive, negative just before I even think about it. And then it's time to go off to the side and do what we do a lot. And that is break down the square root. And we put branch, branch, root, root. What are the magic numbers for 48? It is. And that's just what experience gives us, is just that recollection, that recognition. I see a number and I know what to do. That's why we practice. So 16 and 3 are the best combo for 48. 16 is rooted, so it becomes a 4. And then I just write 4 root 3, and I put a box around this, and I am done. So my answers are 4 root 3 and -4 root 3. Good. All right, it's time for the last one then, and you guys get to try again. So the last one is another square root problem. So again, my thinking is, and I'm going to draw this box again. I know you guys don't draw these on your papers, and I've given up over the years trying to tell kids that they have to, but trust me, it helps. Draw that box and remind yourself, that is my objective. I am not ready to square root yet. I need to get that boxed thing because it's the thing that says squared. Get it by itself. And what do we have to do? Divide by 9. And this is a good example. It's like a good contradictory sort of example to the last one, in that this time it isn't going to come out to a whole number. And that was not an accident. I want to make sure that you're familiar with both scenarios. So I'm going to get 3 plus 4x in parentheses still, and still squared, equals a fraction of 25 over 9. When it can't divide, We don't try. If you learn 5 things from me this year, as you head into whatever class you take next, let that be one of them. When things don't divide, just write them as fractions. It's okay. We like that. It's good. Now what do we do? Now we square root. Your green lighted wants the rooty part or the squarey part is by itself. And so now if I square root the left, I just get 3 plus 4x. Nice and clean. And then before I go jumping ahead and thinking about doing math, I write equals and I write positive, negative. Just make it a habit. How do you square root a fraction? You do. And the square root of 25 is, and the square root of the 9 is 3. Now we got a few steps left to do. Got to just do them in order. Math is like that. Math is not, this is an art class where we express ourselves. Math is very procedural. You do this, and then you do this, and then you do this. That's how it works. So I'm going to subtract that 3 across first. And when I subtract it, I'm going to be tucking it right in there. Right where that little arrow goes is always where your mover should go in these positive, negative problems. So my next line is going to say 4x equals negative 3 plus or minus 5 over 3. And what is the next step? Make a common denominator. You're faced on the right-hand side with a whole number. It's actually not a whole number. Whole numbers can't be negative, but I just say that. It's like a whole number and a fraction. And you cannot add things like that. You have to make the one that's not a fraction into a fraction. And so negative 3, I'll switch colors here and work somewhere else. Negative 3 has to be changed into a fraction with his bottom the same as the bottom of the other fraction. And what's the trick for that? You multiply the whole number by whatever you want his bottom to be. Negative 3 times 3 is negative 9. So to color code this for you, this red box is going to replace this red box like that. So the next line, and I'll show a little bit of work here, is going to say 4x equals negative 9 thirds plus or minus 5 thirds. And now that the bottoms are the same, I can put them together. So what that's going to look like is, let me move, follow the blue arrow. I'm going up here. So now I have 4x equals, mash it up, negative 9 plus or minus 5 all over 3. There's still a couple of steps left. These inevitably should be your least favorite problems. Once you get good at this, you start to pick the ones that become the most annoying, and they're the ones probably that you wind up liking the least, because there's like 8 steps to do when you feel like you might be done. It is what it is. Next step. Right, and remember that dividing by 4 really means to multiply the bottom of the fraction by 4. When you multiply the bottom of a fraction, you actually make the fraction smaller, which is what we want. So we wind up now with x equals negative 9 plus or minus 5 all over 12. And then at this point, it's now time to write your final answers. And your final answers are going to be the answers to the pathways. So this is a pathway problem because all of the roots have disappeared. So we're going to wind up, if we trace the plus pathway, what is negative 9 plus 5? So one of our answers is negative 4 over 12, which is negative 1/3. Done. Pathway done. And now I'll circle the other pathway in green. The pathway is called minus. What is negative 9 minus 5? It is negative 14. And what does that reduce to? So your other answer is negative 7 over 6. Done. So that's stuff that you should, at this point, know how to do. I'm not necessarily saying that there's something wrong with you if you didn't get them right, but that, from my perspective, is where I need you to be right now. You need to be able to factor, you need to be able to use the formula, and you need to be able to use square roots. So I'm going to give you the second snapshot. All right. Same drill. I'd like you to get it done. When you get it done, feel free to bring it up to me.